Hello and welcome to another video of Tutoring with Liah. Today I'm going to be talking about how to balance equations. And I'm going to also go over 4 practice problems. Towards the end of this video, I'm also going to be giving a tip on how to deal with decimals in your coefficients and how to get rid of them. Also, for those of you who are interested, I offer science and math tutoring. So if you want to, you can schedule a session with me by directly contacting me through Instagram and making sure that you include your level and the subject and the topics that you're working on. The link to my Instagram can be found in the description box below. Alright, so let's start off with a really simple example. Balancing equations is just about making sure that the number of each element is the same on both the reactant side and the product side. When we read these equations, we know that the reactants are on the left side and the products are on the right side. Alright, so let's get started here. First, I'm going to start by counting the number of atoms of each element for each side. So let's start with hydrogen. Hydrogen on the reactant side has 2. So there are 2 atoms of hydrogen on the reactant side because this little 2 here is just saying that we have this. But instead of writing these 2 H's, we just write a shorthand and put the little 2 subscript there. Next, I'm going to count the number of atoms of oxygen for the reactant side. And the same thing goes here. I have this little 2 telling me that there are 2 atoms of oxygen on the reactant side. Now, for the product side, I do the same thing. How many atoms of hydrogen? Well, I know that this little 2 only applies to hydrogen. So there are 2. And for oxygen, there is only 1. There is no subscript, so it is assumed that there is only 1 atom of oxygen. Now when I look on both sides, I see that my hydrogen atoms are balanced. That is, they are the same number of hydrogen atoms on the reactant side and the same number of them on the product side. Now if I look at my oxygen atoms, these are not balanced because I have 2 over here and I have 1 on the right side. So I need to balance this equation. And the way to balance equations is to add stoichiometric coefficients, that is, the numbers in front of these compounds or molecules. That is the only place you're allowed to add numbers in order to balance an equation. And so here, I know that I need to have 2 atoms of oxygen on the product side. And so what I'm going to do is if I add a 2 here, so now after I have added the 2 here, in front of the water here, I'm going to recount. So this 2 is going to apply to the oxygen, and it will also apply to the hydrogen, which means that now I have 2 atoms of oxygen, and I also recount my hydrogen atoms. So the 2 here, meaning the stoichiometric coefficient, is going to apply to all of the elements in that compound that it is in front of. So here I have 2 of these, but each of these H2s is just 1 hydrogen. And so I know that in total, I have 4 hydrogens. Now we see that the oxygen atoms are balanced, but the hydrogen ones are not, which is okay. We just need to balance the hydrogens now. So here we have 2 over here and 4 over here. Now, if I put a 2 here, we can see that 2 times 2 is going to be 4. So now I have 4 atoms of hydrogen. So now my equation is balanced because I have 4 hydrogens on each side and 2 oxygens on each side. This is going to be balanced. And just to clarify, when you see this, you can think about it as multiplying the coefficient times the little subscript. So this would just be 2 times 2, which is 4. And initially this number of hydrogen was 2, we had to change it to 4. So we kind of can divide, right? If we say, okay, I need 4 of them, but I only have 2. So you can divide and see what you need, which is your new stoichiometric coefficient. Now we have an example that looks slightly longer. However, the steps to balancing this equation are going to be the same as we just did. We need to count the number of each element on each side. So starting with the reactant side, I have carbon. And as you see from the little subscript, I have 4 atoms of carbon. The subscripts only apply to the elements which they are directly after. So the 4 only applies to carbon, not to anything else. Going on, I have hydrogen, and from this little subscript, I have 10 of those, and oxygen, I have 2. Going on to the product side, again, I count. So carbon. See here, there's only one atom of carbon. And for hydrogen, I have here 2. And for oxygen, well, I have them in 2 places on the product side. I have 2 right here, and I have 1 here. So we know that 2 plus 1 is going to be 3 oxygens on the product side. Now, I can compare each side. Clearly my carbons are not balanced. I have 4 on the left side and 1 on the right side. My hydrogens are also not balanced. They are different. And oxygen is not balanced either. Okay, so everything is not balanced. So in this case, when we start putting coefficients here, we start balancing the elements that appear once on each side, meaning they should only appear in one compound on each side. Looking at our equation here, we know that carbon appears once on each side. It appears here, and it appears over here with this CO2. Starting with carbon, if I divide 4 divided by 1, I get 4, meaning that this is my new stoichiometric coefficient, which needs to go in front of the carbon dioxide on the product side. Every time that you add a coefficient, it is wise to recount all of your elements on that side. So our new numbers, I now have 4 carbons, and this 4 also applies to the oxygen. So what I need to do is to multiply 4 times 2, which is 8. So 8 oxygens in the carbon dioxide, plus remember I have 1 over here with the water. So 8 plus 1 equals 9. As I compare both sides once again, I now see that my carbon atoms are balanced. Usually you want to leave the hydrogens and oxygens for last. That's just a general rule. As you see, they appear quite a lot here. Now, it would be easier now to balance the hydrogens. As you can see, they appear once on each side as well. Now, I have 10 on the left side and 2 on the right side. If I do my division again, 10 divided by 2, I get 5. So 5 is my new coefficient, which goes on the right side because on the right side we are lacking hydrogen atoms. So I put my 5 here, and now I recount all of my elements on the right side again. We still have 4 carbons because we didn't change this coefficient over here, but our hydrogen and oxygen numbers will change. So now we know that we have 10 hydrogens, and we have now, there were 8 oxygens for the carbon dioxide, plus, remember, the 5 also applies to our oxygen, so 5 times the implied 1 here, which is not written in chemistry. So 5 times 1 is 5, is 12. As we see here, we have 12 atoms of oxygen on the right side and only 2 on the left side. If I do the division again, 12 divided by 2, I get 6. So 6 is going to be my new coefficient. Now where do I put it? Of course I'm going to put it right here because this is where it would apply to oxygen. If I tried to put the 6 here, that wouldn't work because over here there's only carbon and hydrogen. Wonderful, so now I recount my atoms on the left side, and I see that my carbon and hydrogen numbers stayed the same because I didn't put a coefficient right here that would apply to them. I only put it next to the oxygen. So now if I do 6 times 2, I know that I have 12 oxygens on the left side. So now I compare my numbers again. 4 carbons, the same on both sides, as is the 10 hydrogens and the 12 oxygens. So because all of these numbers match up, this equation is now balanced. This is another combustion reaction if you are wondering. We can tell that we have a hydrocarbon plus an oxygen gas on the reactant side, yielding carbon dioxide and water for their products. Now back to balancing these equations. The same steps apply. I'm going to count the atoms of each element on each side. So for carbon I have 8, because of the little 8 subscript here that only applies to carbon in this case, and I have 18 atoms of hydrogen, and I have 2 atoms of oxygen. Now that the reactant side is done, I'm going to move on to the product side. For carbon, I have 1. There's a little implied 1 here, but because it's 1, we don't write it in chemistry. And I have hydrogen as well, which I have 2. And oxygen. So oxygen, once again, I would have 3 because there are 2 right here, and there is 1 right here, but it's not written, it's just 1 here. So 2 plus 1 is 3. Clearly nothing matches up here, but let's start. So if there are 8 carbons on the left side and only 1 on the right side, I can do division again. 8 divided by 1 is 8. So I can put an 8 right here where my carbon is. You will be adding the coefficient to the side that is lacking that number of that element. Okay, so now recounting, I have 8 times 1 carbon, which brings my number of carbons up to 8. Then I have that it also affects oxygen. So I do 8 times 2, which is 16. And remember, I also have that extra oxygen right here. So 16 plus 1 is 17. Wonderful. And our number of hydrogens wouldn't change because there was no coefficient that applied to it that we added here. So looking to compare these, I see that the carbons are now balanced. Now moving on, I go with hydrogen next, as it also appears once on each side. So I have 18 on the left side and 2 on the right side. I can divide. So if I do 18 divided by 2, I know that is 9. So 9 needs to be my coefficient that affects hydrogen. So now I do know that I have 18 hydrogens, and now I need to recount my oxygen. Because always remember that the 9 here will apply to oxygen and to hydrogen. Now for recounting my oxygen, I have 16 for carbon dioxide, and I have 9 because this is just 9 times 1, but we don't write the 1. So this is going to be 25. So now we have that the carbon and hydrogen atoms are balanced on both sides. But now we have that oxygens are not balanced. So once again, I can just divide here. 25 divided by 2 equals 12.5. 12.5 is the new coefficient in front of oxygen. However, we cannot have these numbers after the decimal point in the coefficients. They need to be whole numbers, not fractions, not decimals, not anything else, just whole numbers. So even though 12.5 times 2 is 25, and that would balance our equation, it wouldn't really because we have this 12.5 here. It's not a whole number. We have a decimal. And so what we do is we need to get rid of this 0.5. Now, 0.5 is just the same as 1/2. And we know in fractions, when we are seeking to simplify them, that if we put the same number on a different level, meaning this 2 is on the bottom here, and this 2 is on the top of the fraction bar here, we can cancel these out, and we can get rid of the 2, okay? We're going to use the same principle here to get our balanced equation. We are going to multiply every coefficient here by 2 in order to get rid of this 0.5. So if I multiply everything by 2, okay, there is an implied 1 here, but as you know in chemistry, we don't really like to write 1s, so it's just there, but it's not written. So if I'll just write it here for practice sakes. If I multiply every coefficient by 2, I'm going to get 2C8H18 plus 25O2. Just going to put this in parentheses so we don't mistake it for a 250, which is going to yield 16CO2. And finally, we're going to have 18 waters. Every coefficient was multiplied by 2 to get our new balanced equation. If you want to double check that this is actually balanced, feel free. Count the number of carbons, then count the number of hydrogens, and count the number of oxygens for each side, and see if they match up. If you remember, previously I showed that they did match up, but it was unaccepted because of this decimal here. We just multiplied everything by 2. So they're still going to be balanced because everything was doubled. We did the same thing to each one. All right, now we have our final example here. We have this glucose molecule here, could be referred to as a simple sugar, plus the oxygen gas, and yields CO2 plus water. we follow the same steps again to balance this equation. For carbon, I have 6 atoms on the reactant side. I have 12 atoms of hydrogen. And for oxygen, well, I have 6 over here plus 2 over here. 6 plus 2 is 8, so I have 8 atoms of oxygen. Next, I move on to the product side. For carbon atoms, I have 1. Remember that implied 1. For hydrogen, I have 2. Remember, subscripts only apply to the element that they were directly after. And for oxygen, for the product side, I have 2 here, plus 1 here. So 2 plus 1 is 3. Okay, nothing is balanced yet. Starting with carbon, I'm going to divide 6 divided by 1, which is going to give me 6. So on the product side, I have a new coefficient of 6 in front of CO2, which means that every time I add a coefficient, I need to recount. For carbon, on the right side, I have 6 of them. For hydrogen, nothing changed because we didn't put anything here. So this 6, remember, only applies to this compound, not anything before or after the plus sign or the arrow. Oxygen's number, however, was changed. Remember, when we figure out the number here, it is 6 times 2. It's just multiplication. So 6 times 2 for carbon dioxide would be 12. And 12, remember, we have to add it to this 1 oxygen over here. 12 plus 1 is 13. Okay, great. So we have our carbons balanced. Let's move on to our hydrogens. Here I have 12. Here I have 2. If I divide, again, the bigger number divided by the smaller number, I get 6. 12 divided by 2. So 6 is going to be my new coefficient for water on the right side. And now I get to recount. Carbon stayed the same because there's just 6 times 1. Hydrogen, I know it's 12. 6 times 2, right? And for oxygen, I have 12 for the carbon dioxide plus 6. Remember, this is just 6 times 1. And so this is going to be 18. So now my carbon and hydrogens are balanced. Now I need to balance the oxygens. Because the oxygens show up in 2 places, in 2 of the molecules on the left side, I am not going to divide 18 divided by 8. Instead, I'm going to see what I can do about this 18. So if there are 18 atoms of oxygen on the right side, okay, that's our goal, how do I get the oxygen number of 18 to match on the reactant side? Okay, so I have 6 here. If I have 6 there, that removes the weight of 6 of them. So 18 minus 6 is going to be 12. Now 12 atoms are left. And I know that I can easily fix that by putting a 6 here. Now, why is it a 6 here? Well, if you see here, if this is the only thing I have to fulfill, after subtracting the fulfillment of 6 oxygens, right, from the glucose, then I only have 12 more to fill. And if I only look at O2, I know that 6 O2 is going to give me 12 atoms of oxygen. And so now, if you recount, then oxygen here is going to be 18. There's 6 here, plus 12 here. 6 plus 12 is 18. So now that my numbers match up, I know that this equation is balanced. Thank you so much for watching this video. I really hope you found it helpful. If you did, please remember to subscribe and leave a comment down below.